Hello everyone, this is Gokir. Today I'll be giving our last talk and I'll be talking about SQL injection, which is one of the most frequent and serious security issues present in database systems. Databases are now supporting virtually every application that runs on internet-based infrastructure on banking devices and or social media platforms, and any form of vulnerability in the way they are accessed can result in significant issues, including data compromise, data loss, or unauthorized access. SQL injection involves the injection of malicious SQL code into an input, example, a login form, to the database to do damage. Say an attacker enters something like 1 equal 1 instead of the standard username, a trick that can fool the system and make it bypass authentication or return data it doesn't want to have accessible by the user. This occurs because the system cannot adequately validate or sanitize user input, and which trust is invested in data that has not been checked. Furthermore, malicious programs make input in memory to include cookies or system accesses vulnerable, and attackers can use the system security mechanism to gain access to the specific request being processed. From an actual scenario, SQL injection has led to massive data breaches with millions of user details exposed. Many of the early systems were particularly vulnerable because they failed to employ secure practices such as parameterized queries or prepared statements. Developers nowadays become more cognizant of these weaknesses and are more likely to employ secure practices to elevate these risks, such as input validation, secure coding approaches, and newer frameworks. SQL injection demonstrates the paramount importance of secure development, considered it from a cybersecurity lens. In a compromised database, sensitive information can be released, a system can suffer integrated damage, and an entire system can fail. That is exactly why companies spend so much money on penetration testing, ethical hacking, and ongoing security upgrades. SQL injection also raises significant ethical questions. Malicious hackers and ethical hackers, actually, there's a big difference. Ethical hackers identify vulnerabilities first before attackers can take advantage, but then there are boundaries that ought to be respected. It is, for example, unacceptable to test on a system without permission, even when it says to be more secure. This also raises matters of data ownership and responsible revelation of weaknesses. Ethical hacking can be taken from utilitarian standpoint and is justified in terms of protecting numerous users, but from a deontological point of view, unauthorized access remains morally wrong despite the consequences. This sets in motion a cycle of doing what is right in return and right from a legal and ethical standpoint. SQL injection reveals to me that security is not only a technical concept but also a human endeavor and a matter of ethical responsibility. It's upon the developers to write the secure code, and the developers must take charge of ensuring that the code is written securely, and organizations must take charge of user data security. Ethical hackers are crucial contributors to security improvements, but they cannot do it all. They must always be legal, ethical hackers, and ethics. Unclear rules of engagement and accountability mean that the lines between securing an application and exploiting to the machines are blurred. At the end of the day, it's a great story of the dire impact that small errors can have from code, and this is an important lesson that you need to have technical competence and ethical sensibility mixed together in our ever data-driven generation of the information age. Thank you for listening.